Good morning, everyone. Welcome to my talk that's called More Than Syntax. My name's Patrick, and you can find me under Huesler on Twitter. I've been told, too, that you should not give out your name on stage by a trainer, but I think that's just rude. So I agree with Aaron on that, and I should introduce myself. More Than Syntax was the original name of the talk, but on my way here, I changed my mind, and I pivoted on my talk like a good startup does these days. So I changed it to Web APIs with ERLANG, a Ruby developer's point of view, in which I'm going to talk about how you can write web services in ERLANG and how you can have your Ruby tools that you do off your environments and your automations and your deployments, all stuff like that. If you can have that in ERLANG, that's what I've been trying to do in the last 3 months. Also, on a very important note from yesterday, Terence Lee is not a liar, because apparently he gave an interview yesterday telling that he's looking forward to live coding in my talk, and that's not going to happen. Because I changed the talk again because I cannot code and frame coherent sentences. It's just not how I work. So I will spare you the embarrassment and I skip that. So Terence Lee's not a liar. In fact, he's awesome also with his work on Railscross. So, snowboarding. Cool topic for Hawaii, I guess. So, but bear with me. I grew up in Switzerland in the mountains. I grew up in snow. So snowboarding, skiing, ice hockey, you name it, I did it. There was even one incident where I actually would go to kindergarten with my skis on. So I'm fairly proficient in snowboarding. I know how it works. Which brings me to surfing. For one reason, I have this slide so I can actually wear board shorts on stage as a prop. I don't feel embarrassed. But also because I wanted to learn surfing, and I thought it would be easy. Knowing how to snowboard, I thought it's just a piece of cake, you just do it. So I actually did read a book on surfing, every detail how you do it, and I thought, well, that's great, I can do it. It's very similar to snowboarding, no problem. So one day I actually went out surfing, and I got my board shorts, or in fact, in Europe, you most of the time need a wetsuit because the water is too cold. So I went out, I did the surf check, checked where the waves are, where the currents are, where the lineup is. And I wanted to paddle out. I fell off the boards. First thing I didn't know, those things are pretty wobbly. So I couldn't even paddle that thing. So the next roadblock that I hit was trying to get out, but I managed to get around this. Then I was paddling on my first wave. I paddled it on. I was quite confident. I would stand up, and I had a great feeling that this is going to be like snowboarding. And this is what happened. And this is what's happened the whole afternoon. So the lesson here is sometimes just reading a book and banking on your previous knowledge and that being transferable to your new skill sometimes doesn't really cut it. Which brings me to ERLANG. Same story here, or similar story, just with Ruby and ERLANG. So just a quick check. Who here has looked into ERLANG? Wow. Who here has written production code in ERLANG? This one. OK. I think we should be good. So I am actually an ERLANG beginner as well. I've only been using it productively for a couple of months. I started getting into it like 4 years ago, but I never went further than the chat server Hello World application. So that also means you shouldn't believe like it's a beginner's perspective. So there might be some stuff in there that an experienced ERLANG developer would just go, no, that's not how we work. So if you find something like that, please let me know after the talk, and I'll try to correct it. And I will not cover an introduction to ERLANG. I think I'm not able to in the first place. Other people have done this a lot better. I will more focus on the concepts and on the stuff that I had to built to have like my Rails Ruby mindset tools working in Erlang, and preferably the Erlang way, so not trying to shoehorn Ruby ways into Erlang. So I will focus on that, and there's going to be a lot of content, a lot of code. It doesn't. I will not go into every detail, but it's fine. I put everything up on a GitHub repository, and I deployed the application to Heroku, so you can check up on that later on. Just to make sure we're on the same page, a quick Erlang refresher. It is a functional language, so it's based on the mathematical paradigm that your code, everything is a mathematical function that you work with. It tries to avoid state and mutable data, which turns out is extremely useful for stuff you build in Erlang. It's a compiled language that builds bytecode that's called beam files, and that gets executed by a virtual machine that handles everything and handles the connection between nodes and clusters. And there's Erlang OTP, which is a set of common practices, patterns, and abstractions that help you build great applications in Erlang, like a generic server, like state machines, and event handling. So why Erlang? First of all, because Corey Haynes likes it. And if that's not good enough for you, I've brought the bigger guns even.
Hello, my name is Bjarne Dekker, and I'm responsible for the computer science laboratory. Our job, that is to put research to work. And our main challenge, that is how to program large real-time systems as efficiently as possible. And after many experiments, we decided that we had to move from conventional high-level languages such as Ada, Chill, C++, etc., into the world of declarative programming. We also found out that the only way to do that was to develop our own language, and a language which is called ERLANG. In this video, we'll show you about the properties of this language and how it's been applied in large prototyping projects, and also about the potentials of this language for the future.
So, should you, when you start writing Erlang code, maybe right after this talk, should you ever get stuck? Instead of asking yourself what Freddie Mercury would do, ask yourself what that guy would do, and you might actually find the answer. So why Erlang? From my perspective, it is seriously concurrent, and it was built for that. So both CPU and I/O concurrency, and you don't have to bother whether you want to use non-blocking I/O, blocking I/O, event machine, and stuff like that. It's just built in there. You can do both. And you can have synchronous calls and asynchronous calls. It's just there for you. And it is built with actors, which is a great model of concurrency that uses message passing and it makes sure that you have no shared data that could get corrupted, and you have to deal with locks to make sure only one person at the time is actually accessing that data. And you can see actors in the Ruby world, for instance, in a framework called Celluloid, which is building an actor framework for that, and which runs actually quite nice on JRuby and Rubinius. And it is distributed. So networking is almost trivial in Erlang. Talking to other machines, building other services, talking about service-oriented architecture if you want. That's just right in there in Erlang. And you can see the power of it if you look at distributed databases like CouchDB or Riak that are written in Erlang. So these are the core, it's one of the core strengths of Erlang. Another one is it's fault tolerant. Erlang systems are built to run all the time, and they expect failure. And one of the philosophies is actually let it crash, because you have infrastructures that will restart things when they go wrong, and you can have really fine-grained strategies. What happens when something goes wrong? What gets restarted? And can build up whole hierarchies. And I'll explain one of my favorite features by Bill O'Reilly.
Okay. We'll do it live.
Okay.
We'll do it live. Fuck it. Do it live. I'll write it and we'll do it live. fucking thing sucks!
In 5, 4, 3.
So, that ever happened to you, that you actually wanted to do stuff live on the production system because you were running out of time, and you didn't have, and you wanted to go home, you wanted to go to bed or something, and you just weren't in the mood to apply the proper tools, you just needed a quick fix. And Erlang is a compiled language, remember that. So, but it allows you to do hot swapping. So you never have to take down the whole virtual machine, you never have to take down the whole system. It has infrastructures to upgrade your code, to reload your code, and you can go and compile code and change stuff around and reload it without ever taking it down. But it also has a lot of good infrastructure to do this in a very controlled way if you want to. And you have a remote shell. You can attach to every node in your Erlang cluster and get like an IRB, but within the context of the running virtual machine. So you can inspect processes, you can inspect memories, you can turn on login for certain users, and so on and so forth. So the way we use Erlang at WOOGA, that's the company I work for, the reason why we started using it is because we do games on Facebook and on iOS, games like Monster World, where you share data with your friends. You can look at the garden of your friends. You create your own friends with nice little decorations. And you can go to your friend's garden and help them out, water their plants, send them magic gifts and mystery gifts. However, there are a few technical challenges involved when it comes to a backend system, because our biggest game, Diamond Dash, has roughly 20 million users every month. I think I took that data early October. And on a daily basis, that is like almost 4 million users. So for a backend system, that can mean a lot of traffic that you have to deal with. So the peak that I took from that game, Monster World, that I showed earlier with the garden, was 6,500 requests per second. And that wouldn't be always a problem, depending on the traffic. But the problem is, for us, it's the database where it really hurts. And the reason why that is, most requests are writes. So your classic go-to solutions like caching, adding read slaves, is not going to cut it. So we optimized our databases for a long, long time until we figured, well, there must be something else. And Polo, one of our engineers, came up with a great different architecture that he decided to build. And this is my interpretation of it. And he never said that, but this is my interpretation of it, is that no database. We're going to have a stateful application. So the user session will live in memory. And we just write everything on S3. Just get rid of the pain point database completely. And the way it was set up was, imagine you go to Facebook, you click on a link, you start playing your game, a logging call gets to the server, a coordinator system service will assign a new worker to it or create one, which then will lock that data, will lock that user session, so to make sure nobody else is writing to S3 while it's on. And then it will load it from S3, and from then on, the user would actually play to the data in memory right away. And asynchronously in the background in certain intervals, it would save it back to S3. So if you lose a few minutes of data, normally it's not that big of a deal for those kind of games. And the logout is the reverse. Release the lock, write back to S3 and release the lock and terminate the session. And typically for the game that was initially built for, I think that's like roughly 20 minutes. And the reason why it wanted to build that in Erlang is because in Erlang processes are cheap. So every user session is a process, and you can run 30,000 user sessions on one machine if you want to. Try that in Ruby. Try to fork 30,000 Ruby processes on one machine. It's just not going to work. So the way it is set up in Erlang is your processes live inside your virtual machine. And if I'm correct, there is one operating system thread per CPU that the Erlang VM is managing, and it will make sure it runs concurrently. And this is also a bit the way of Erlang thinking. You just move stuff out into processes, that you can also move around because you don't need to know where the process is. It could be on your machine, it could be on another machine. If you know its PID, you just can talk to it, which is a really powerful construct of ERLANG. So, let's talk web APIs. I want to talk about environments, loggings, as we know it from Ruby, and from Rails and Sinatra, testing, and actually deploying it to HEROKU. The first tool that I normally use for many of those things is called REBAR, which is a mixture between your Rails command and Ruby gems. It was written by Basha, the guys who built Riak. So to start out, you create a new application like this, and this will create you a skeleton for you. And ERLANG has this concept of applications built right in. So your application might actually exist of several applications that you start. Think of it as services that you use. Or you can also look at it as gems, depending on what you do. So we'll set up that structure. And then, of course, you normally have a lot of dependencies in your code that you want to write. I'm talking about external libraries that you want to have, a MySQL client, or a certain piece of functionality, a web server, things like that. Something you normally specify in a gem file, right? REBAR does this again for you. And then it gives you the commands to get your dependencies, to compile them, to compile your code and compile the dependencies code. Those are the most commonly used commands that you use in REBAR. And the configuration file looks a little bit like this. I know it's not pretty, but these are proper ERLANG structures. So you tell it the name of the application, tell it what revision you want, what Git repository it is, and what revision you want. And then you run REBAR get dependencies, and it will fetch all the dependencies. Next thing we need is a web server. There are a couple of ones in ERLANG. One of this is there's MOCHIWEB, there is Web Machine, there's Cowboy, there is Yaws, and we, however, Knut, one of our engineers, we actually built our own server. For some reason, we didn't like everything in Cowboy, and we wanted to have more control of the request lifecycle and get more insight into what's happening inside a request, which is really important for us for monitoring. We have a lot of dashboards, and we really want to make sure we detect problems early. And so here we can actually see on a socket level what's happening. And it's very little code. I even contributed some, and I think it's a couple of pages of code. A complete web server in ERLANG that is quite fast. It's a lot faster than every Ruby thing that I've seen so far. So here's the first ERLANG code, but I think since you're all familiar with it, I will skip the details about modules and functions. So you pass in a callback module, which is like your Sinatra base class that you pass in that implements certain functions that get called when a request comes in. And you pass in a port. And next thing you want to do is routes, right? Because only having one endpoint normally doesn't cut it. And so I've looked into it, and I've built my own router that looks something like that. I've built my own Rails style router where you can define a path, an HTTP method, and you define if this route is happening with this HTTP verb, then call my handler with that method with those arguments. And then you will match it. If you find it, well, you get a 404 or something, and otherwise you will actually call that function on that module. And then it took me one morning to write that, and I was extremely proud. And I talked to one of our more seasoned programmers, ERLANG programmers that is, and he was just laughing at me. He said, "You're doing it wrong." What he only told me a couple of weeks later is that he made the same mistake, I think 2 years ago. But at first he wouldn't tell that me, he would actually make fun of me. So he said you have to use pattern matching. Is everybody familiar with pattern matching? Okay, let me change that question. Is anybody not familiar with pattern matching? Okay, so Here it is. What you can do in Erlang is, and also other functional languages, is you can extract certain parts of your data by giving, if you have an equal sign, you can have your data on the left and a pattern how you want to extract your data on the right, and on the left of the equal sign you can have a pattern how you want to extract that data. For instance, if you look at the foo_bar method, this is a function definition header. So you already say, okay, I expect a string, which is a get, and I expect a list as a second argument with the two items foo and bar, which is the split path as a list that you get in from Ellie. So it can automatically extract it, and if that doesn't work, if Erlang cannot match that pattern, it will go through all those methods until it eventually comes here, because this is sort of your wildcard matching, right? You can think stars in regular expressions, something like that. So you match that, which is an extremely powerful concept that you also use inside your functions, but you have this often directly in your functions. You have functions with the same name, but different parameter settings and different specific matchings, which gives you a really powerful and really idiomatic way of doing things. Because here, if you look at method number 5, line number 5, you know this is a GET request on foo/bar, right? So the slash is sort of omitted away, but everything else is actually really clear. And you have it really central, like you know it from Sinatra. So, middleware. Who here likes rec middleware? Who uses it? Not as many as I thought, too. All right. I'm a big fan, because you can abstract functionality that is generic and just take it out into its own thing and reuse it across applications. Yeah, for instance, for logging, for monitoring, for exception tracking, you can just plug that into your rec middleware. And we wanted to have that as well for Ellie, and so they built it. And the way how you do it, it's quite similar to how you tell it which is the main entry point for your web API. You just give it the name of your modules that are middleware, and they will again get called certain events that happen inside Ellie. There's a list of those events. So most of them might not be very interesting to you. I mean, the most interesting normally for me is request complete. But also you can tell whether the client closed or the client timeout, had to time it under the connection. Honestly, I don't really know how you would detect that in Rails, that the client timed out. And for us, this is actually sometimes important, especially when we have long-running connections that are kept open. Here, this is the request complete event that you would get. So the beauty of this is, look at all the events that you get. You can actually tell when the request started, when the headers ended, and when the body ended, and the request ended. So with all those, you can actually detect mobile clients, for instance. There are a lot of clients that will start sending the header, and then it will take forever until they start sending the body. So, and with that, you can actually detect that. So that allows for awesome monitoring solutions. We normally use something like New Relic in Ruby. There isn't support in Erlang yet. I think some of our guys are actually working on that. So you can build crazy good dashboards with your, and just plug in a dashboard middleware that will collect data and send it off to a dashboard service. And it can, because you have all that information about users without actually touching your core functionality of your web service. Here are when something goes wrong, if you want to do exception tracking. So if a request gets thrown, if it gets exited, or if there's an error in general. Okay, let's move on to environments. Right? If you have a sort of more or less serious application, you will have a testing environment. You will have a staging environment, a CI environment, and a production environment. And they probably have a different configuration. So I looked into all the solutions that I could find in the Erlang world, and there are many of them. There is some stuff with dynamic module loading. There is setting up a configuration server inside your application. But this all was a bit too complicated for me. And I almost gave up until I found the most obvious solution possible. You can pass in a config parameter into the Erlang command line util. So reading the man page of the tools you're using sometimes really helps, because it spares you a lot of time. Config file. So this is an Erlang property list, where you can look at it as like a key value thingy, where it's in a tuple. The first value is a key, and the second value is the actual value of it. And here we define for our Aloha application, we'll define the work report. And later on, we have other applications that we are using inside our applications that we define here. And we'll look into that right away. Logging. You can learn a lot from your log files, especially for operations, and see what's going on. And specifically turn on logging for certain users. See your slow queries and slow database queries. See certain user events that happened. You get a better idea what happened with that user at that time, for instance. And then you can, for instance, take all that data and push it into a dashboard service or a graph and visualize what's happening. So for operations, this is a really excellent tool to have great logging. However, the standard Erlang solution is not what I had in mind. It's you have a logger class, and you can have the regular log levels. And you have also something called SASL, which is a more complex error logging solution and slash service that gives you a lot of information, and you can do complex stuff. However, the problem is this. It generates way too much content. You don't need to know most of that. And I was looking more for having beautiful one-liners that you know from Linux, like you know from Apache, from syslog, or from services, or from Nginx. You know, those great little one-liners where it's time-stamped and then some log entries that you can beautifully pass around into syslog and distribute it over your system, or whatever you want to do with it. And they're a lot easier to parse with your standard Linux tools, right? So using grep on something like this gets really complicated, because then you get one line, but you don't know the context where it came from, because the date is a line above. So yeah, how about more Linux-style version of it? Turns out there's another tool also written by Basho, as it happens. So it looks like they have many of similar ideas that other people have as well, that they want to have in Erlang. And we looked at the config before. So starting from line 7 to line 17, you can config everything out of Logger that you possibly ever need. You have file backends, you have syslog backends, and those backends you can enable tracing for certain functions. So when a request goes through, you can enable that, and Logger will do that for you as well. So it's a very versatile solution and very flexible in terms of logging, and it gives you those nice little one-liners that you can grab just as easily. And the way you use Logger, this is your application file that REBAR created for you when it generated it. And so you have to start up Logger. But not only have you start up Logger, you have to start up 2 more applications. Here it's compiler and syntax tools. And Logger doesn't tell you this, and I think it's not possible that it can. And this is a common problem I had with Erlang, is I never knew what dependencies an Erlang tool or library that I was using had. So this is like a Ruby gem that has not specified its dependencies probably in a gem file. But actually, you go on a hunt, right? You try to run it, oh, this is missing. Install that, and oh, this is missing, install that. And you get really annoyed by that. So there's a fix that one of our guys wrote. Because what Erlang does, if you start an application and one of its dependencies cannot be started, it will actually tell you that it could not be started and which one it was. So you just start that. Is everybody good with the amount of Erlang code, or is it going too fast? take the nodding as a yes. Oh, even a thumbs up. So, yeah, then you get the classic aloha. When a big, does anybody ever know what the freak set is when surfing? So it's a set of waves that actually does, normally waves break at a certain point. And this is where the lineup is, where you see all the servers paddling around. And when a freak set comes in, it's further out. So that normally is not a big problem unless you have really big waves. For instance, Mavericks. There, when you see a freak set coming in, you see people paddling for their lives to get just out of there. Otherwise, they get buried under their waves. So freak set is a warning, and if you don't consider it a warning, you eventually actually wipe out. Talking about unit testing. Important tool, and I want to use ERLANG with unit testing as well. The standard that everybody's using is called eUnit. Good enough. I kind of liked it. I used it initially until I noticed something. You don't get stack traces in eUnit. For a long time, you didn't have stack traces in ERLANG at all. I think until 14. And with 15, you actually have stack traces, which is a big improvement. You can get eUnit to give you stack traces, but you need to patch your ERLANG, I think. Somebody told me that the patch didn't make it into the release. So, which for me was a no-go, because you run a test, and as an error message, you get undef. And you have no idea where it happened, what test it was. You're just standing there looking at undef. So you start uncommenting code until you figured out what the problem is. So we have etest for that, which is essentially like any unit testing framework you can think of. So it's nothing special. It has the classic setup and tear down methods. It has assert methods, like assert equal. And those are macros in the ERLANG world. And of course, there's a lot more macros, but you can look that up. You don't need me to tell all this. And then you have a nice little test runner, which is actually written in Ruby, because it was built by Ruby guys. Some more water. How about integration testing? We're building web services here. There are big integration testing frameworks for ERLANG, and it always took me way too long to get that to work and set up the HTTP client to do stuff. And so some of our guys also figured that was a problem. And I came up with an extension to eUnit, not eUnit, what was it? etest, I'm sorry. And here we go. It's called etest HTTP. Same structure. Here it's important that you start up your application before you run requests against it, because if you don't start up your application, it will not accept any HTTP requests. So this is actually doing a proper HTTP, as you can see on line 20. And it will generate a proper request. And you can assert your status, your body. There's support built in for JSON, because most of the APIs we do are actually JSON. So you don't have to go manually all the time, JSON parse, and figure that out. So it does that for you. And you run it the same way. One of my favorite features, auto reload. Remember, it's a compiled language. So classic use case is you write your code, you save, you compile, you start the application. Then you would change something, you would make your code, compile, stop the application, kill the application, and start it again. So this cycle always takes a few seconds, and it's just getting you really slow, especially if you're like messing around with it, and not necessarily to test through development, it's just messing around with it, right? And since ERLANG allows you this hot code reloading, you can do it, and you don't have to build it yourself. MOCHIWEB, which is a good web server written in ERLANG, inside in its source code, you find a reloader module that you can just install and tweak it to your likings. And then you just start your reloader in your application startup, and that's it. What it will do, it will monitor your Beam files, which are your compiled ERLANG source files. And then it will, if they changed, it will reload the code for that module. There is, however, one little exception, which are the native extensions in that would be the Ruby version of it. They're called NIFs, native interfaces. With reloading is, it normally works the first time, and the second time, it just blows up in your face. To an extent, it kills your whole ERLANG virtual machine. When I try to reload Jiffy, which is a JSON C library that we are using for fast JSON parsing. I think they're working on it to make it work, to make Jiffy work with hot code reloading, but you might need to change your reloading code to not reload certain libraries. Autocompile, I think for all you Ruby experts, it's probably a no-brainer. I'm using Guard because I think it's written by Swiss guys. I don't have any preferences. I'm just showing you Guard, but you can use whatever. There's Watcher and there's FS events. Essentially, you check for all these source files, and then you run REBAR compile. And then your auto reload code is going up. So this way, you can actually just change code, hit save, and play around with it, and your code is getting reloaded and it's executed. You don't have to go through the whole life cycle again manually. So it becomes a lot like Sinatra or Rails development in development mode, where you don't have to restart the whole world just to see one little change. Then we're almost done. All we need to do is deploy that now to HEROKU. I just learned that last week, actually, that you actually can do that. I'm just waiting for a HEROKU employee to take a picture. So, who here uses HEROKU for whatever? Side project, fun projects. Awesome, so that's most of you. So we can go through that quickly. So you create your HEROKU app. That's standard. Then you have, with the cheddar stack, you have those build packs. So you can run different architectures, different languages inside HEROKU. And so you're no longer restricted just to Ruby or whatever HEROKU gives you. You can build your own build packs to run whatever on HEROKU. Building one is a bit brittle. I had a few problems. Luckily, somebody at HEROKU built one for me. This one is only ERLANG version R14. I couldn't get it to work with ERLANG R15. I'll have to look into that. But yeah, you just add the build pack URL and you're set. It runs ERLANG. The PROCFILE that you need to start and stop your HEROKU application is also straightforward in ERLANG world. You have your ERL command. You have to give it the path to your dependencies so ERLANG can find all your modules and all your code. Then you have your no shell, no input to make sure it's not it's not doing something interactive. And you pass it in your configuration, and then this is what I really like about ERLANG. You can actually pass in here to tell it to start up the application Aloha app. So what we will do is, for you, we go application start Aloha and start it up for you. And that's almost it. You don't really know on which port HEROKU is talking to you, or I couldn't figure that out. So what I actually found is that you have an environment variable called port that says what you have to listen on. And so the ERLANG version for that is actually, yeah, it's here, the nitty-gritty. Oh, here, this is, by the way, how you read out your configuration on line 7. Whatever we had in our application configuration, this is under the key Aloha, and then you have our work report. And here we check if there's an environment variable called port. We use that. If not, and convert it into an integer. If not, we just use our default. So development version works. FOREMAN that I use, FOREMAN start. That's it. And the actual deploy. Yeah, it's beautiful how simple that is in HEROKU. You all know that. It's just git push HEROKU master. And there you go. And then you get some a lot of output. It compiles everything and it fetches all the dependencies. And voila, you can curl. This is actually live. I built that. Aloha URL heroku.app.com/aloha, and it will get back a response. I think something I took from Wikipedia. It's something about cows. So you'll figure it out. And this is the app. And this is also where you will find all the codes that I talked about. You will find a ready-made application that you can start using and start building your web services. And I'm also planning to turn that more into a generator, so it's more like a Rails command. So you say, I need a new web service with Ali, and boom, it sets up everything for you, because right now I had to do everything manually. So yes, go out and write your first web services in ERLANG, learn something about a new language, learn new paradigms, and get new ideas how to improve your Ruby skills, how your programming skills, learn new concurrency patterns, learn about the actor model. There's so much great stuff inside ERLANG that I haven't covered here, because ERLANG was built for something completely different what we normally do. It was built for telecommunications, stuff that's always up, stuff that's distributed, stuff that's always fault tolerant. So they put in a lot of thought and work into that. That's all I got. Thank you.